Okay, so our fifth property, a over b all to the power negative n, is written as b on a all to the power n. Now let's prove this. Here we are going to have a to the power negative n over b to the power negative n. Okay, this can be written as a to the power negative n multiplying 1 over b to the power negative n. Now here, a to the power negative n can be written as 1 over a to the power n multiplying here 1 over b to the power negative n will be written as b to the power n. Then we continue. This is going to give us 1 multiplying b to the power n, which is b to the power n, over a to the power n. And we can further write this as b over a all to the power n, which is a proof of what we have over here. Now let's pick our sixth property. So for our sixth property, it involves square root. So we have square root of a. Understand that the square root of any number is the same as the number raised to the power 1 on n. So square root of 8 will be written as a to 8 to the power 1 on 2. So when it comes to square root, the denominator of the exponent is always 2. If we have cube root of a number, it can be written as the number raised onto the power 1 on 3. If we have fourth root of a number, it can be written as the number raised onto the power 1 over 4. So how the radical sign is read tells you how the exponent will be. So cube root of a is a raised onto the power 1 over 3. Now what about this? Cube root of a to the power 2. Understand that the cube root will be written as what we have here, all raised to the power 1 over 3. When we continue, we are going to have, we've learned that a power raised onto another power will multiply. So we are going to have 2 multiplying the numerator, which is 1. So 2 times 1 giving us 2 over 3. So you can try this. Fifth root of 16 to the power 3. So you can pause the video, and fifth root of 16 to the power 3 will be written as 16 to the power 3 all raised to the power 1 on 5, which is further written as 16, then 3 multiplies the exponent. So 3 times 1 gives us 3 over 5. So these are some of the properties and indices. Okay, so we have this on the board, 16 over 81, all raised to the power negative 3 on 4. If you remember, or if you go back, the same video, we proved this property. And we learned that a over b raised to the power negative n is written as b on a all raised to the power n. So this is going to be written as 81 on 16 all raised to the power 3 over 4. And we learned that the exponents affect each of them. So we are going to have 81 to the power 3 on 4 over 16 to the power 3 on 4. Now here, there's no need to just focus on the denominator. Ask yourself, in what way can I write 81 to have an exponent of 4? If you don't have a calculator, just apply factor tree, where we have 81 giving us 3 times 27, giving us 3 times 3, 3 times 9, then 3 times 3. Here we have 1, 2, 3, 4, which means that 81 can be written as 3 to the power 4, all raised to the power 3 on 4, divided by 16. Now here too we have a denominator of 4 for the exponent. So ask yourself, how can 16 be written such that it will have an exponent of 4? Apply your factor tree and you are going to obtain 2 to the power 4. So here too we have 2 to the power 4, all raised to the power 3 on 4. And from what we've done so far, we multiply. So 4 times 3 over 4, this 4 cancels out. So now we are left with 3 here onto the power 3. Then here also 4. So the same, 4 cancels 4. We are left with 3, which is 2 to the power 3. And 3 to the power 3 simply means 3 times 3 times 3, giving us 27 over 2 to the power 3, giving us 8. You can continue and break this one down. Let's take a second question. We have 64 over 25, all raised to the power -1 on 2. So you pause the video and you try the question. Okay, so let's solve this question. So from what we did here, we are going to have 25 on 64, all raised to the power 1 over 2. This is the same as 25 raised to the power 1 over 2. It's a property we've already expounded. On 64, all raised to the power 1 over 2. Now, always look at the denominator. Ask yourself, how can we write 25 such that it will have an exponent which is the same as the denominator here? So we know 25 and the factor tree is 5 times 5, which is 5 to the power 2. So this is giving us 5 to the power 2, all raised to the power 1 over 2, over 64 2 can be written as 8 to the power 2, because 8 times 8 is 64. So our 8 to the power 2, all raised to the power 1 over 2. And now we simplify this. Remember, 2 multiplying 1 over 2. 2 cancels out the 2, and we are left with 1. Which means now when we solve this, we are going to have 5 to the power 1. We are not going to write the 1. Over here, 8 to the power 1. And this is Florent, the mathematics tutor. Follow me on TikTok, Facebook, and YouTube. On YouTube, the channel is Florent, the mathematics tutor, and same for TikTok. But on Facebook, it is Saliu Florent. Thank you.